Okay, chapter 3.3, completing the square. Essential question, how can you complete the square for a quadratic expression? How can you complete the square when you don't know what completing the square is? Well, we'll learn. What you will learn this chapter, solve quadratic equations using square roots, solve quadratic equations by completing the square, write quadratic functions in vertex form. Okay, so solving quadratic equations using square roots. Previously, you have solved equations of the form u squared equals d, chapter 3, 1 or 2, I can't remember which, by taking the square root of each side. This method also works when one side of an equation is a perfect square trinomial and the other side is a constant. All right, let's take a look. Okay, example 1. Solving a quadratic equation using square roots. Okay, so I'm going to show you this two different ways. And let's start with the way we normally do it. We want to get 0 on this side. So if I subtract 100 from both sides, I am going to get x squared minus 16x minus 36 equals 0. Okay, now I want factors of c that add up to b. That sound familiar? Have I said that before? Factors of c that add up to b. So I want factors of negative 36 that add up to negative 16. Okay, so factors of negative 36 are negative, and I want a negative, so I know my larger number is the negative and my smaller number is positive. Negative times a positive is negative. A big negative plus a small positive gives you a negative sum. All right, and then 36 times 1, negative 18 times 2, and 3 is 12, and 9 and 4 and 6 and 6. So I want the sum of these now. So that's negative 35. It's not negative 16, so it's not the answer. Negative 18 plus 2 is negative 16. And that's what I was looking for. So I'm going to use these two values. So it's going to be x minus 18, x plus 2 equals 0. And the zero product property just simply states that the opposite is the answer, because 18 minus 18 is 0, and 0 times anything is 0. So that would have to be 18, and this x would have to equal negative 2, and it can't be and, it must be or. Okay, so we got x equals 18 or x equals negative 2. All right, so now let me get this out of the way. I did not solve this the way they said. It said solving a quadratic equation using square roots. So I'm going to redo this again. X squared minus 16x plus 64 equals 100. So the key to this is still factors of c that add up to b. So if I want a square root, if I want the square root of a polynomial or a trinomial, then I want the square root of c divided by 2. And that will be b. Okay, so let me write this over here. B divided by 2 squared equals c. Or the square root of c equals b divided by 2. Okay, so what I'm saying is I want to see if this is a perfect square, and it is. The square root of 64 is positive or negative 8. And when I take that square root, b is half, or half of b should be that number. So if I double the square root, this isn't right. The square root of b, so if I took the square root of both these, c would equal b over 2. No, that was right. All right, so the square root of c, the square root of 64 is 8, and that has to equal b over 2. Well, b is negative 16 over 2 is negative 8. So what that means is if you have a perfect square, which we do, you can write it as this. So if I foiled this, remember 8 minus, or x minus 8 squared is the same as x minus 8 times x minus 8. And if I FOIL that, x times x is x squared, x times negative 8 is negative 8x. Negative 8 times x is another negative 8x. That adds up to negative 16x. And a negative times a negative is positive, and 8 times 8 is 64. So this is I took the square root, or I found the perfect square to set this equal to 100. So see if C is a perfect square, and if it is, double the square root and you should have B. All right, so now to solve this, I take the square root of both sides, and I'm going to get x minus 8 equals plus or minus the square root of 100. So I'm going to rewrite this as x minus 8 equals the positive 10, or x minus 8 equals negative 10. If I add 8 to the other side here, I get x equals 18, which matches here. And if I add 8 to this side and this side, I get x equals negative 2. And that is what I got over here. So sometimes it's easier to identify that if this is a perfect square, you take half of it and double it. And if it's that, then you can just do the x with this sign. Half of that squared is going to equal the other side. All right, so after this example, try to do 3, 5, and 6 following what I did in green, not in red. Okay, so in example 1, the expression x squared minus 16x plus 64 is a perfect square trinomial because it equals the quantity x minus 8 squared. Sometimes you need to add a term to an expression x squared plus bx to make it a perfect square trinomial. This process is called completing the square. So in this core concept, completing the square, words to complete the square for the expression x squared plus bx, we have to add half of b squared, which I said on the last page. Diagrams in each diagram, the combined area of the shaded region is x squared plus bx. Adding b over 2 squared completes the square in the second diagram. So let me try to explain that a little bit better. So if let me change the color to, let's see, line color red. So if I focus on this piece right here, all right, this is a square that is x by x. So the area is base times height, which is x squared. This is a rectangle of height x because it's the same height as the blue one, and it's got a length of b. So what we're going to do is cut that in half and put the other half down here. So we want to shrink this down to this size right here. This is a little difficult. Give me a sec. Okay, so I want a box that size. So I'm going to rotate it and move it down here. Okay, so what I've done is I've got a square length, a rectangle length b with a height of x, and I cut it in half. So this would be 1/2 bx, and this is 1/2 bx. So what we're doing is taking b divided by 2, and then we need to square that because b over 2, since this was length b, now this is b over 2, this side, and this is x, and this is x, and this is b over 2. So it's b over 2 times x for the area, and that's where this comes from. So this is b over 2 times x, as it says right here. And so this is gone. It got moved over to here. And now I have a square that's not complete. Now I have this going on. So I moved this one that I crossed out inside here. So now I need this piece. And in order to do that, you have to take b over 2 times b over 2 to get here, if you're familiar with this type of diagram to find factors. All right, so then we get x squared plus bx plus b over 2 quantity squared equals x plus b squared times x plus b, I'm sorry, x plus b over 2 times x plus b over 2, which equals x plus b over 2 quantity squared. Okay, so all we're doing is taking what's inside the parentheses. So the half of c is what goes in as our perfect square. So b over 2 is 1/2 c. Okay. B over 2 squared is c. So the square root of b over 2, I said 1/2. It's not 1/2. The square root of b over 2 is c. Okay. Anyhow, let's move on to another example. Okay, example 2, making a perfect square trinomial. Find the value of c that makes x squared plus 14x plus some c a perfect square trinomial, then write the expression as the square of a binomial. So let's start out with x squared plus 14x plus, and I'm not going to put c there, I'm just going to leave it blank. So the first thing you do is take 1/2 of b. So I'm going to say b equals 14, so therefore b divided by 2 equals 14 divided by 2, which equals 7. So you take half of b and square it. So 1/2 b squared equals 7 squared, which equals 49. So I'm going to add 49 right here. So now I have x squared plus 14x plus 49. That is a perfect square trinomial because the square root of c times 2 is b. Then it says rewrite the expression as the square of a binomial. So it's going to be x plus 7 quantity squared, or you could write it like x plus 7 times x plus 7. Okay. Either one, I mean, writing it like this, it doesn't show the squared, so really it should look like this, writing it as a square. So it's the quantity x plus 7 squared. Okay, now try to do that with 11, 14, and 16. Okay, example 3. Solving a standard form quadratic when a is 1. So here a is 1, and we have x squared minus 10x plus 7. So before, let me explain why we complete this square. If I were to just jump right in and go like this, I haven't really explained why we complete the square. I need factors of 7 that add up to 10 to make this true. So when you do a factor tree for 7 or a factor table, it's 1 times 7, 7 times 1, and that's it because 7's prime. When you add those two, you get 8, not 10. So these are not integer solutions. So we can't do it that way. And that's why we have to complete the square. So here's what we do. Step 1 is we have to get our constant c over to the other side. So I'm going to start out by writing x squared minus 10x, leave some space, equals -7. Be careful when you subtract 7, it becomes negative on the other side. Okay, so now we want to complete the square. Now don't forget that c equals half of b squared, and I need a c right here. I have a is 1, b is -10. I do not have a c anymore, so I need one. So I need to take half of 10. So if you divide this by 2, then I'm going to get -5, and -5 squared is 25. So I'm going to add that here. Okay. This is no longer true though, because I added 25 to the left and I didn't add anything to the right. So once you find c by taking half of b and squaring it, that has to get added to both sides of the equation to keep it true. So let me get this out of the way now. So this gets pretty routine. After you do a few, take half of this and square it, it goes here and here. Okay, now we go on to the next step, and we now have a perfect square, by the way. So I can do this, and this is x, and b over 2 is what we put here. So half of negative 10 is negative 5. So x minus 5 quantity squared. If I wrote this out and wrote x minus 5 times x minus 5 and did FOIL, we would get x squared minus 10x plus 25. These are two equal statements. And then we add 25 to negative 7 and we get 18. So I have x minus 5 quantity squared equals 18. Take the square root of both sides and I get x minus 5 equals the square root of 18. Now I'm going to do this off to the side. The square root of 18, if I simplify that, is 2 times 9, which is 3 times 3. I have a pair of 3's that becomes the number outside. I have a pair of 3's that becomes 1 outside, because 3 squared is 9 and the square root of 9 is 3, and I still have a 2 underneath the radical. So I have 3 square root 2. So this is going to be plus or minus 3 square root 2. I'm not done yet. I need to solve for x, so I'm going to add 5 to both sides. Let me stop right there, though. Let me rewrite this as two equations. X minus 5 equals 3 square root 2, or x minus 5 equals a negative 3 square root 2. That's what plus or minus means. Add 5 to both sides in both equations. Be careful, you cannot add a radical that's being multiplied by a number to another number. So this would be simply 5 plus 3 square root 2. And this one over here, if I add 5 to both sides, this would be x equals 5 minus 3 square root 2. Okay, so if you want, you can then combine these and say, all right, so since we have this and this, and we can simply say x equals 5 plus or minus 3 square root 2. So obviously this is an irrational root, and factors of 7 that add up to negative 10 can't do it, so you have to complete the square to solve this. Well, it's one way to do it. Okay, so after this example, you should be able to do these 4 problems. Please try them, and let's move on. Okay, example 4, solving a standard form equation, ax squared plus bx plus c equals 0, this time when a does not equal 1. So here we have a is 3. So before I start, I'm going to write a equals 3, b equals 12, c equals 15. So if I were to factor this, the first thing I want to do is get rid of this 3. So I'm going to divide both sides by 3. So let me write 3x squared plus 12x plus 15 equals 0. So if I divide everything by 3, you have to divide every term. Then you're going to get x squared plus 4x plus 5 equals 0 divided by 3 is still 0. Now I have a equals 1, b equals 4, and c equals 5. So b divided by 2 is 4 divided by 2, which is 2. Okay, and b divided by 2, which is 2, squared would equal 2 squared, or 4. So I'm just writing this all down for you to get you in the habit. So half of 4 is 2, squared is 4, but I need to move this 5 over here first, remember from the last example. So it's going to be rewritten as x squared plus 4x, skip a space, equals negative 5. And half of 4 is 2, squared is 4. What you do to one side, you do to the other. So the c you find gets added to both sides. So now we have a perfect square, and it's x plus half of b squared equals negative 5 plus 4, which is negative 1. Take the square root of both sides, and I'm going to get x plus 2 equals, okay, from the last chapter section, I can't remember if it was 3.2 or 3.1. we dealt with this square root of a negative. It's an imaginary unit. I'm just going to put plus or minus the square root of -1 for now. And I need to subtract 2 from both sides. So it's going to be x equals -2 plus or minus the square root of -1 is I. So this is what's called a complex number. Part of it is real, part of it's imaginary. Together it is complex. So my answer to this problem is an imaginary complex solution of -2 plus or minus I. Okay, hopefully you understood that. Let's recap. First thing you do is divide everything by A to get your new quadratic with A equal to 1. Move C to the other side. Take half of B, square it, create a new C, and add that to both sides, and take the square root and solve. Okay, so now try 25, 26, 31, and 32. Okay, example 5 is writing a quadratic function in vertex form, not standard form. So in writing this in vertex form, the first thing you do is write y plus, leave a space, equals x squared minus 12x plus, leave a space, plus 18. So what we're doing is we're trying to find a perfect square trinomial here and then a constant off to the side. Okay, so we take half of -12, which is -6, square that, that's positive 36. That goes here and here. So then we have y plus 36 equals all of this. This is now a perfect square, so I'd write y plus 36 equals x minus 6, quantity squared, plus 18. Okay, get this y by itself by subtracting 36 from both sides, and we get y equals x minus 6, quantity squared, minus 18. That tells us my vertex is at 6, -18. It's a parabola opening up. A is 1, and we are done. There's a quadratic function in vertex form. So just leave a space next to y and next to your bx and move c out of the way, and you're finding a perfect square c, and then it all falls into place. So try that with these 3 problems. Okay, example 6. Take me out to the ball game, modeling with mathematics. The height y in feet of a baseball t seconds after it is hit can be modeled by the function y equals -16t squared plus 96t plus 3. Find the maximum height of the baseball. How long did it take the ball to hit the ground? So we have 2 questions we're being asked. So we've got this dude at bat right here. Didn't know I was an artist, did you? So here he is, has ball cap on, and he's got his bat. Okay, and this +3 means that the ball was at 3 feet when he hit it, and he hits the ball. The ball comes off the bat and it goes up a certain amount and it comes down and it lands on the ground. The maximum is going to be our axis of symmetry vertex, if you will, the vertex on the axis of symmetry, which is right here, x equals, and I put an x here because I was thinking about it. It is actually h comma k. That is my vertex. Axis of symmetry is x equals a certain time after the ball was hit, where t is time. And the height of it will be the k at that time. So what we're going to do is we're going to write the equation, just going to rewrite it, -16t squared plus 96t plus 3. All I did was rewrote the original problem. And I'm going to factor out that a. I'm going to take -16 away, and I'm going to leave t squared in. So -16 times t squared is -16t squared. A negative times a negative is positive, and 16 will go into 96 6 times. So I get this Okay, so I want to complete the square inside here. So now I'm going to write y, and I'm going to add something here, and I'm going to leave a space, and it's going to equal negative 16 t squared minus 6t. Half of negative 6 is negative 3, squared is 9, so it's going to be plus 9. I don't know why I have a squared symbol here. It's not supposed to be. All right, the only squared is right there. I got ahead of myself. So it's negative 16 times t squared minus 6t plus 9 plus 3. Okay, now be careful here. I added 9 here. Let me change that color so you know that that was my b divided by 2 squared. Okay, 9. I don't just put 9 over here. I do put 9, but I don't put just 9. If you look here, negative 16 is outside this parenthesis. So negative 16 is being multiplied by 9 if I distribute. So I need a negative 16 over here as well. So that is going to give me y minus, because a positive times a negative, and a negative 16 times 9 is 144 equals negative 16. And then I can do my perfect square now, t minus half of b. Quantity squared. This is where I want to square, not up here. And then plus 3. Okay, so far so good. So now all I have to do is get that 144 over to the other side, and that is going to leave me with y equals negative 16 t minus 3 squared, and add 44 to 3, and I get 147. Okay, so that is my vertex, h comma k. So my vertex, this point right here, the maximum is 3 comma 147. So what that means is after 3 seconds, the ball reached a maximum height of 147 feet. Okay, after 3 seconds. So the next thing is, now remember, the ball was hit at 3 feet. So we can't just say, well, it took 3 seconds to go this way, so it's going to be 3 seconds to when it hits the ground. It's got to go the same distance to the 3 feet in 3 seconds. So here's 3 seconds maximum, down for 3 seconds to get to the 3 feet, same y value as it started. And it's got to drop 3 more feet, and that's going to take more time. So I know my answer is going to be a little greater than 3, but not quite 3. So how do I find that? Okay, well, we want to find the 0. We want to know when this is equal to 0. So I'm going to say 0. Let me change colors now. I'm going to write 0 equals negative 16 t minus 3 squared plus 147. Okay, and I'm going to subtract 147 over to the other side. And that's going to leave me with negative 16 t minus 3 squared. So I'm going to divide both sides by negative 16. And that's going to leave me with t minus 3 squared here. Let me get the calculator, and I'm doing 147 divided by 16. So 147 divided by 16 is 9.1875. So that's 9.1875. So I just divided by 16. And then when I continue now, I want to get rid of that squared. So I take the square root of both sides, and I get t minus 3. And let me extend the page here. T minus 3 equals the square root of, or plus or minus the square root of 9.1875. And then I add 3 to both sides to get my value. So the time t is going to equal, I'm going to run out of room on that side, so I'm going to flip it around, symmetry here. T is going to equal this 3 plus or minus the square root of 9.1875. Okay, so the square root of 9 is 3. So the square root of 9.1875 is a little bit more than 3. And if I take 3 minus a little more than 3, I'm going to get a negative. So in this situation, we are going to eliminate the negative sign because we can't have a negative time. It makes no sense. So we want this portion. So t is going to equal, so I'm going to do the square root of 9.1875 plus 3. So I take this, and I'm going to take the square root of what I just did, my answer, and that is 3.031 plus 3. So it's 6.031. So it's approximately 6.031. So I'll do an approximation. So the time is approximately 6.031 seconds. Okay, that's how long it took the ball to go from the bat up to the maximum at 147 feet, back down and hit the ground. And the reason for the additional 0.031 seconds is because it had to drop from the 3-foot marker. Because it started at 3, the y-intercept, going up to the maximum at the vertex took 3 seconds. Back down to the 3-foot mark would be another 3 seconds, and then that fraction of a second to go the other 3 feet to hit the ground. So did we answer the question? Find the maximum height of the ball, 147 feet, and how long it took the ball to hit the ground, 6.031 seconds. Okay, so now you should be able to do problem number 63 on your homework. Okay, that brings us to the end of chapter 3.3. Hopefully you've already done all of these after each example, but this is the assignment for this chapter section. Have a great day.